To the untrained eye, it looks like a common field daisy. Pristine white petals around a cheerful yellow center, swaying in the summer breeze. But do not let its beauty fool you. This is not a wildflower. It is a biological weapon. For centuries, this unassuming plant was the nuclear option of the ancient world. It served as the invisible shield that protected soldiers from typhus in the trenches of the Napoleonic Wars and guarded the grain stores of the Silk Road. It contains a chemical complex so sophisticated that for over 100 years, modern chemists could not perfectly replicate it. It is a neurotoxin that strikes with the speed of a lightning bolt, paralyzing its target in milliseconds. But the most miraculous trait of this plant is not how it kills. It is how it vanishes. Unlike the synthetic poisons that now saturate our soil and water, this assassin does its job and then disappears, broken down by the very sunlight that fed it. We traded this self-cleaning botanical shield for a legacy of industrial chemicals that never leave. This is the story of the Dalmatian Daisy, Tanacetum cinerariifolium, the forgotten guardian of the garden, and the quest for convenience that poisoned the world. Welcome to Ancestral Yields. If you want to protect your food without poisoning your soil and uncover the forgotten tools of agricultural history, please like this video and subscribe. The origins of this white assassin are steeped in European folklore. In a legend from the 1840s in Dubrovnik, modern-day Croatia. The story goes that a local woman named Ana Yusufbegović noticed something peculiar in her parlor. She had picked a bouquet of wild daisies growing on the rocky cliffs nearby, intending them for decoration. But as the weeks passed, the flowers withered and dried in the corner. When she went to sweep them away, she found a ring of dead insects, flies, ants, and beetles surrounding the vase. They were dying upon contact with the fallen, crumbled dust of the flower heads. Crucially, she noted that the drying process did not weaken the plant, it concentrated the power. Anna did not keep this secret to herself. She took her observation to a friend, Antun Drobak, a renowned pharmacist and naturalist in Dubrovnik. This is the moment the history changed. Drobak did not dismiss her. He tested the powder. He realized that this local weed was a biological cousin to the Persian chrysanthemum, Tanacetum coccineum, which was already being traded along the Silk Road as a luxury insecticide. However, Drobak's analysis revealed a startling economic truth. The local Dalmatian species, Tanacetum cinerariifolium, was vastly superior. It contained far higher concentrations of the active toxin than its Persian cousin, and it bloomed more aggressively in the harsh, arid soil of the Adriatic coast. Drobak began paying locals to harvest the wildflowers, processing them into a fine dust he marketed as Dalmatian insect powder. The results were undeniable. By 1850, it was not just a local remedy. It was a strategic commodity. Farmers across Dalmatia began ripping out their vineyards and olive groves to plant this white daisy. It became known as the green gold of the coast. By the late 19th century, this powder was the only effective defense Europe had against the lice and fleas that plagued the crowded tenements of the Industrial Revolution and the barracks of imperial armies. It was shipped by the ton to New York and London, valued nearly as highly as gunpowder. All because one woman noticed a ring of dead bugs in her living room, and a pharmacist had the wisdom to listen. But the balance of power shifted in 1881, when an Austrian trader passed the seeds to a Japanese entrepreneur named Shichiro Ueyama. Ueyama didn't just see a flower, he saw an industry. He took the seeds back to Japan and industrialized production in Wakayama Prefecture. Ueyama is credited with inventing the spiral mosquito coil, a mixture of pyrethrum powder and sawdust that is still burned in summer evenings across Asia and the American South today. By utilizing the volcanic soil and humid climate of Japan, Ueyama built a monopoly. By the 1930s, Japanese farms were producing nearly 90% of the world's supply of pyrethrum. This botanical monopoly would soon turn a garden flower into a strategic military asset. If this plant is so effective, safe, and renewable, why did agriculture abandon the Dalmatian daisy? The answer lies in the geopolitical crisis of 1941. Following the attack on Pearl Harbor, the United States was instantly cut off from Japan, the supplier of 90% of the world's pyrethrum. This was a catastrophe. The United States military was heading into the Pacific Theater, a war fought in jungles teeming with malaria-carrying mosquitoes and typhus-bearing mites. They had lost their shield exactly when they needed it most. Desperate, the USDA poured resources into chemical research. In 1949, a team of USDA chemists led by Milton Schechter synthesized alethrin, the first pyrethroid. Farmers and chemical companies had a single complaint about the natural flower. It did not last long enough. They viewed the plant's best safety feature, its rapid breakdown in sunlight, as a product defect. They did not want to spray every few days. They wanted to spray once and kill bugs for a month. This demand for persistence drove the development of the next generation of synthetic chemicals, type 1 and type 2 pyrethroids, such as permethrin and cypermethrin. Chemists deliberately altered the molecular structure, adding cyanide groups and halogen atoms to make the molecule photostable, resistant to sunlight. They succeeded, and in doing so, they broke the cycle. These new synthetic pyrethroids do not vanish. They linger on the leaf, in the soil, and in the water. They act as landmines, killing the target pest on Monday, but continuing to kill bees, butterflies, and lacewings for weeks afterward. Because the chemical stays in the environment, insects are constantly exposed to sublethal doses, which accelerates the development of resistance. We traded a biodegradable, renewable flower for a permanent pollutant. We chose the convenience of a monthly spray over the health of the biosphere, turning a temporary intervention into a permanent toxicity. So, knowing it was once the world standard, how do we reclaim this lost technology in a modern American garden? The tragedy is that for decades, home gardeners were told this plant was too difficult to grow or process. That is a myth. The Dalmatian daisy is hardy in USDA zones 5 through 9. It is a perennial, meaning once you establish a patch, it returns year after year. It originates from the limestone cliffs of the Adriatic, which tells you everything you need to know about its soil requirements. It needs full sun and gritty, well-draining soil. If you live in an area with heavy clay, like the American Southeast, you must plant it on a slope or in a raised bed amended with sand or gravel. Sourcing the correct seeds is critical. Do not buy generic painted daisies or chrysanthemums at a hardware store. You must look for Tanacetum cinerariifolium. Reputable heirloom seed houses like Earth Care Seeds are your best bet. Do not confuse this plant with its lookalikes. The common oxeye daisy looks similar, but lacks the pyrethrin punch. You can tell them apart by examining the leaves. The oxeye daisy generally has spoon-shaped, dark green leaves. The Dalmatian daisy has deeply lobed, fern-like leaves that are silvery green and soft to the touch. Never forage for these in the wild, along roadsides, because wild daisies are often sprayed with the very herbicides we are trying to avoid. Harvesting requires strict timing. The active compounds are concentrated in the seed head, the achenes, located right in the yellow center of the flower. You must harvest when the flower is in full bloom, but before the petals start to fade or droop. Processing is where we have to address the turpentine factor. Historically, American farmers in the 1920s extracted the pyrethrins using harsh solvents like kerosene or turpentine to create crude barn sprays. We do not need to do that today. The most important rule of processing is light sensitivity. You must dry the flowers in the dark. If you dry them on a windowsill in the sun, the ultraviolet light will destroy the toxin, leaving you with useless hay. Use a dehydrator or dark closet with good airflow. Once dried, you have two distinct options for processing. The first is to create a dust by grinding the flower heads into a fine powder using a dedicated grinder. This dust can be puffed onto plants for contact killing. Alternatively, you can create an extraction by soaking the dried flowers in high-proof alcohol like vodka or in a neutral vegetable oil for 48 hours to extract the active compounds. After straining, this results in a potent concentrate. This leads to the flashbang strategy. If you have a sudden invasion of aphids or Japanese beetles, apply your homemade pyrethrum at dusk. It kills the pests overnight. By the next morning, sunlight breaks down the residue, and you can release beneficial insects like ladybugs into the area 48 hours later with zero risk of collateral damage. The active ingredients in that yellow flower head are a group of 6 complex esters collectively known as pyrethrins, including pyrethrin 1 and pyrethrin 2, cinerin 1 and cinerin 2, and jasmolin 1 and jasmolin 2. While modern poisons work by destroying tissue or shutting down organs, which is a messy and slow process, pyrethrum acts as a surgical strike on the nervous system. It targets the voltage-gated sodium channels in an insect's nerve cells. Think of these channels as sliding doors that allow electrical signals to pass through the nerve. When a mosquito, flea, or beetle contacts the oil of this flower, the pyrethrins bind to those channels and jam the doors in the open position. The result is catastrophic for the insect. The nerves fire uncontrollably and continuously. Toxicologists call this the knockdown effect. The insect becomes paralyzed almost instantly, dropping from the air or from a leaf before it can feed or reproduce. But here is the biological miracle. This mechanism is specific to cold-blooded invertebrates. Mammals like you, your dog, or your livestock have a biological lockpick. Our livers contain enzymes called carboxylesterases that hydrolyze or break down the pyrethrin molecule with incredible speed. We metabolize it faster than it can harm us. However, there is an important safety warning to heed. While safe for humans and dogs, this plant is highly toxic to cats and fish. Felines lack the specific glucuronidation pathway in the liver necessary to break down these compounds efficiently. Even natural pyrethrum can cause tremors and seizures in cats. Likewise, fish are incredibly sensitive to it. Never plant this near a koi pond or natural waterway. A high-grade dried Dalmatian Daisy flower head contains roughly 1.3% to 2% pyrethrins by dry weight. To put that in perspective, just 100 grams, or about 3.5 ounces, of dried flowers can yield nearly 2,000 milligrams of active compound. In the world of toxicology, this is a massive payload. It is potent enough that a single pulverized flower head can clear a small room of mosquitoes. The story of the Dalmatian Daisy is a stark reminder that in nature, there are no perfect solutions, only trade-offs. The industrial world traded safety for persistence, and we are now living with the residue of that decision. But the daisy is still here. It is waiting, ready to offer its protection to anyone willing to work with the rhythm of the sun rather than against it. True food sovereignty is not just about growing the vegetable, it is about owning the means to protect it. By planting this flower, you are reclaiming the right to defend your harvest without scorching the earth. It is time to bring the white assassin back to the garden borders. It is time to plant the shield that nature intended. If you enjoyed digging into this lost history, please give this video a like and subscribe to Ancestral Yields. See you in the garden.